Hello everyone, my name is Fadillah Sartin Adam, and I am 241011060054. I am Information Systems Class B. What is graph theory? Graph theory is a branch of mathematics that studies relationships between objects using a structure called a graph, which consists of vertices, nodes, representing objects, and edges representing the connections between them. Graph theory is used to model various real-world problems, such as social networks, road maps, computer networks, and transportation systems. It helps analyze connectivity, find the shortest paths, determine optimal routes, and solve a wide range of network and optimization problems systematically. And what is crossing number? Crossing number is a concept in graph theory that refers to the minimum number of edge crossings that occur when a graph is drawn on a plane. In other words, it measures how many times edges must intersect each other in the best possible drawing of the graph. A graph with a crossing number of 0 can be drawn without any edge crossings and is called a planar graph. Crossing numbers are important in areas such as network design, circuit layout, and graph visualization because minimizing edge crossings generally makes diagrams easier to understand and more efficient to implement. Example: this graph consists of 6 vertices and 5 edges. Initially, the graph has a relatively simple structure, with only a few connections established between the vertices. As more edges are added, the relationships among the vertices become increasingly interconnected. The introduction of these additional connections causes several edges to intersect with one another, creating 3 crossings within the graph drawing. In graph theory, these intersections are known as crossings and are an important aspect of graph visualization. The presence of crossings often indicates a higher level of structural complexity, especially when multiple connections must be represented on the same plane. As the number of connections increases, the likelihood of edge intersections also becomes greater. This example demonstrates how a graph with 6 vertices and 5 edges can produce 3 crossings, illustrating the relationship between graph connectivity and the emergence of crossings in a graph drawing. Second example. In this example, the graph consists of 8 vertices and 8 edges. Initially, the graph contains only vertical edges, creating a simple structure with no intersections or crossings. This arrangement makes the connections easy to visualize and understand. As diagonal edges are added, the graph becomes more connected and visually complex. Some of the new edges intersect with existing ones, creating edge crossings. This example shows how adding more connections can increase the complexity of a graph and make its layout more challenging to represent clearly. 20 to 25 seconds of narration. Third example. In this example, the graph consists of 7 vertices and 9 edges arranged in a circular layout. The circular arrangement provides a clear and organized view of the connections between vertices. As additional edges are added, several crossings appear inside the circle. This demonstrates how increasing the number of connections can make a graph more complex and difficult to visualize.